Hello and welcome to SGN Tech Forum. Today I'm going to show you something really hands-on and exciting, that is how to build a site-to-site VPN from your on-prem network to AWS Cloud or VPC. So why you would like to build this tunnel? By default, when you spin up your instances or your resources in a VPC, they cannot communicate to your remote network or home network unless you attach an internet gateway, right? But many a time our workload is private. That means we don't want to expose it to internet. But still, sometime you have this hybrid kind of requirement where you have some of the servers in cloud and some of the development is happening on-prem, and you want these two different components to talk to each other. How you can connect them? Site-to-site VPN is a way to go quickly and inexpensively. Obviously, it is not the only way. You have other options like site direct connect and etc. But in this video, we are going to build site-to-site VPN live. So uh, grab a cup of coffee and pay attention. All right, what we are going to build? We are going to build, this is exactly the scenario what we are going to build. We have a VPC and we have two private subnet associated in that VPC. Within those private subnet, we have some sort of servers. And here is my on-prem network or home network where we have some resources and we want to connect them together. For on-prem side, as you can see, customer gateway, these are nothing but your on-premise routers. So you have a router on-prem because you have the connectivity outbound. And from on-premise router, we are going to create a VPN tunnel to the AWS construct called Virtual Private Gateway or VPGW. So instead of IGW, we are going to create a VPGW so that we can create an encrypted and secure tunnel between customer gateway and virtual private gateway. All right. So as you can see, there are multiple concepts involved here. You need to know the cloud construct and you need to know the networking technology. All right. So what you can do, it is not first time we are talking about VPN in SDN Tech Forum. You can see I already created this video. So if you are not familiar with IPsec and IKE technology, go ahead and watch this video. Also, if you are not up to speed with cloud construct, you can watch this complete playlist AWS crash course. All right. Assumption is you know about these two technology and you are ready to build something awesome. Before we do that, let's look at the documentation, and most important thing with AWS is you have to understand the pricing. Okay. So what we are looking here is what is site-to-site VPN and what you need to know. You need to know few concept, cloud construct concept like VPN connection, VPN tunnel, customer gateway device, and all those things. And don't worry, I'm going to explain everything. What else you need to know? And I highly recommend whenever you are building something on AWS, please be sure you know about the expenses. You do not want any surprises later on. So for AWS site-to-site VPN, yeah, there are other various version of that. It's classic and accelerated. For classic, it is 0.05 cent per hour, right? And here is a nice example, pricing example. If you are creating a site-to-site VPN, and then you are spending roughly $36 per month. Data transfer, first 100 GB data is free, so you pay 400 GB for 0.09, and data transfer fees is another $36. So roughly $72 you'll be spending per month, which in my opinion is quite inexpensive compared to direct connect and etc. So why anyone will do direct connect? Another rationale is direct connect, though it has more stability and security. At the same time, it has a huge lead time. But one of the key advantage of direct connect is it can scale. The speed can scale maybe 100 GB versus VPNs. VPNs are limited to 4 GB or 5 GB of throughput. All right. So once we know about this, Let's go ahead and log into our AWS Cloud. Here I am in AWS Cloud. Assumption is we have VPCs and subnet available. Before we do that, let me show you something, step-by-step thing, what I'm planning to build here. So let's go and open this up, document. Okay, let me just blow it out so that we can see it. All right, so this is exactly what we are planning to build, right? We have talked about it. What is the technology we are going to use? We are going to use, as I mentioned, you need to know networking construct also. So what we are going to use, we are going to use IPsec Virtual Tunnel Interface, VTIs. So we are not going to build uh, side-to-side VPN using CryptoMap. Those are a little bit legacy technology with their own drawback. We are going to do Flex VPN, that means IPsec VTI, Virtual Tunnel Interface. What is the advantage? This does simplify the configuration and it avoid the uses of GRE. So if you want to run any kind of routing or you want to run multicast, VTIs are are themselves capable of doing that. You do not need another layer of encapsulation or another tunneling technology, which is GRE. Okay, so this is the flavor we are going to build, IPsec VTI. With IPsec VTI, you can send and receive both IP unicast and encrypted multicast traffic on any physical interface. Another big advantage is VTI work just like a regular interface. So you can apply physical interface like construct, QoS, firewalling, and security services as soon as tunnel is active. Okay. IKEv2, this is the flavor we are going to build. There is a legacy flavor which is IKE v1 version 1, but we will be building IKE v2. And what goes into IKE v2? Again, there are multiple series of process happen which you need to know. First is IKE v2 proposal. Define the protection attribute to be used in negotiation of IKE v2 security associations. Think about it like the language. What language you are negotiating, what language both parties can speak. Can you speak English? Can you speak French? Can you speak Spanish? We need to agree on how we can communicate on a platform. So think about it as proposal like that. Then proposal is binded to IKE v2 policy, and IKE v2 policy refer it encapsulates the proposal. Then we have IKE v2 keyring. So this is the who part. So you know how, but we are going to communicate. But then you want to make sure that who you are communicating, and if you are communicating, for example, Alice and Bob, your Alice is trying to communicate to Bob. Alice want to make sure that it is really communicating with Bob. So the authentication comes into picture, which is IKE v2 keyring, and it is glued to IKE v2 profile. All right, and we are going to use pre-shared key in our implementation. So this is the first part, step 1 to 4. This is the initial negotiation phase, and once security association is built, then we are ready to send the actual data, and that actual data require confidentiality and integrity. For that, we are going to use transform set. So we are saying that how we are going to encrypt that data and how we can make sure that data is not tampered during the transit. All these things comes from transform set. And finally, IPsec profile, it is one overarching umbrella which actually bring everything what we discussed so far, how, who, and uh, how, what to use for encryption. It bring everything under one uh, umbrella, and then we can use IPsec profile and apply it to our tunnel interface. Tunnel interface provide a routable interface that can be used to apply other interface features, as we mentioned, QoS and security policies, etc. And you can also use run dynamic routing over it. Again, whatever we discuss here, how they are nested or how they are linked together, this picture show you that. This is So IKV2 proposal goes into policy. Then we have keyring. Keyring goes into IKV2 profile. Uh, and then we have transform set, which is called under IPsec profile. Also, IKV2 profile comes under IPsec profile. And finally, we are calling IPsec profile under interface, tunnel interface. Okay. So this is what you need to know from networking side. Okay. Now I'm going to give you step-by-step instruction how you are going to work in AWS to build AWS side of the construct. Okay. Let me zoom out this a little bit. And these are the steps we are going to follow. Cloud construct. Assumption is you have a VPC. That means you have a AWS account and you have a VPC and you have a couple of subnets associated to this VPC, and those subnets are private. So that is our baseline, because we essentially we want to create a tunnel to talk to servers in this private subnet. From here we will start create the customer gateway, and customer gateway is nothing but the identification or the IP address of your on-prem router. So uh, be sure that you know what is the IP address you are getting from your provider, and so that means you should have an internet connection uh, terminated to your router, and that is the case in my uh, here. So I have a router, Cisco router connected with a service provider, and I have got a IP address from DHCP providers DHCP. So that information you need to know. Then we will create virtual private gateway VPGW, and VPGW is going to be a glue between uh, throughout this VPN connection. Then create a new route table. So obviously we need to create a route table so that whatever routes are here, we can use VPGW to propagate those routes. So route table will be populated, and VPGW will act as a gateway. Now create the VPN connection. This is the main part where you are actually doing all these things: proposal, policy, keyring, profile, and all these things you can doing in step 5. And AWS make it really easy for us to select, or maybe you can live with the default options, and it's very easy to create. So then once you have created the VPN, then AWS goes extra mile and provide you an option to download config based on whatever on-prem device or customer gateway you are using, whether you are using ASA or you are using a router or a checkpoint firewall, whatnot. You will see that AWS give you an option based on how you created your VPN connection. It will allow you to download configuration that you can download, copy, and paste on your customer gateway. Obviously it's not 100%, so you may have to make a some tweak here and there, but it does the heavy lifting. Once that is done, you will see the tunnels will come up. However, as you know, AWS has this security group concept. That means it's like a host level firewall. So even if you have the connection, you may not be able to talk to uh, AWS servers. So you have to make sure that security inbound rules are edited or modified. Once we have done that, we are going to go ahead and verify remote end VPC reachability. That means my on-prem server should be able to reach my cloud VPC resources. And then finally, we will come back and check these things from router itself. So we will also we will do two side of checks, one from AWS side and one from on-prem router, so that we understand how what to check from both sides, cloud construct and networking construct. So with that, I'm going to put this here this side so that I can follow the steps. All right, this is our AWS account. Let's go to VPC, and we are going to follow the steps what I shown you here. So from VPC, let's figure out, you can have multiple VPCs. So let's see with which VPC we want to create site-to-site VPN. I have Cloud VPC here. Let's go ahead, expand this. And what we are interested in is subnets. So as you can see, we have a couple of subnets. Some are private and some are public. So we have private subnets here. All right. So first is good. This is baselined. And now what we want to do, we want to create a customer gateway. And to do so, what you need an IP address handy. Let me show you my IP address. So this is the brand new router with no configuration. Only thing we have is we have internet port connected. And as you can see, I have got an IP address from DHCP. And also what you can see, there are a few other things coming, like someone is trying to log in 159.223. So this router has no security. It is completely exposed to internet, which is not a good scenario. And as you can see, when you are exposed to internet, people try to scan your network, try to SSH to it. And if I go ahead and search this IP address, we are getting a little bit off track here. But as you can see, this is a malicious IP. So always make sure that you secure your outbound port or you use some kind of firewall. Okay, let's get back to our discussion. So step 2 is creating customer gateway. What do you have to do? You have to go to everything related to VPN is here on your left hand side, virtual private network, customer gateway. Let's go ahead and create a customer gateway. I'm going to say create a customer gateway, and this is SDN Tech Home. We are going to, this BGP number comes by default, but we are not going to do BGP. We will actually do static routing from both sides. So this is the IP address. Specify the IP address for your customer gateway device's external interface. So this is my router's external interface IP address. You can add some tags, or you can say which device it is. This is ISR 1K. Create customer gateway. As simple as that. Okay. Once you have created customer gateway, next is create a virtual private gateway. Again, to do so, you have to scroll and come to VPN. From VPN, click on virtual private gateway. Here we are going to create a virtual private gateway. There are a few old ones, but let's go ahead and create a new one. I'm going to say this is SDN VPGW. We are not going to do any BGP, so leave it like this and say create virtual private gateway. The gateway is created. Then what you have to do? You have to connect or attach this gateway to the VPC. Attach to VPC. From drop down, choose your VPC. Attach. This is going to take some time here. Okay, let's start thinking about the fourth construct, which is we have to create a route table and make sure that we are enabling route propagation, so that whatever route is available in this route table, VPGW can propagate it to your VPC. Okay, so you are going to learn remote side routes, and these routes will be propagated to other routing tables. Okay, let's see, this is attached. Now let's move on to route table. Since we already have a subnet, then you can see we have route table, the default route table for public and private, but we want to create a new route table, and I'm going to say this is my IPsec route. Select your VPC. You can optionally add some tags, create route table. And as soon as we created the route table, you can see the entire VPC subnet showing up here as local route. However, the interesting thing is, is it going to be propagated? So it's no. We want to go ahead and say, so what we want to go to route propagation, and we want to say edit route propagation and enable route propagation. Okay, so this route will be propagated. Subnet association, let's quickly check. Subnets without explicit association. So we have two private subnet, 172.16.9 and 172.16.8. They are associated, but you can go ahead and uh, add these subnets. So what I'm going to do, this step is optional, but I'm going to anyways go ahead and associate this subnet. Save association, subnet association, both the privates are associated. All right, so step 4 is done. And if you're wondering why I'm looking other way, I'm just following the steps here. Now create the VPN connection. This is the heavy lifting. Okay, so let's go and do VPN. From VPN, you have to click on site-to-site VPN connection. From site-to-site VPN connection, ignore the old one. We are going to go ahead and say create a VPN connection. We are going to say SDN VPN target gateway type. So this VPN will be attached to VPGW. So think of VPN as a logical tunnel, and this at the end of this tunnel we have VPGW that is attached to your VPC. This is how the tunnel enters the VPC. Select your virtual private gateway. Customer gateway, we have already created that in earlier step. So select that. What do you want to do? Routing option, dynamic. It can only do BGP. However, we want to do static route to keep things simple. Static IP prefix. What is your side of prefixes? So for me, it is 192.168.1.0/24. So we want to use that. Local, these are optional. Leave it like that. Tunnel option. This is the very interesting thing. So what you can do, you can leave everything default and simply create a VPN connection. That's what we are going to do. However, if this is not the best practice, because when you use default value, you are really not using the best or uh, best quality ciphers. You may use weak ciphers. So if you know what you want to build, you should always go ahead and edit tunnel options, like what will be the use in phase 1 encryption, what will be the use in phase 2 encryption, integrity, and so on. However, to keep things simple, we are going to just use default option. And as you can see, AWS builds two tunnel for you. So though you need just one tunnel, but AWS for redundancy, it will build two tunnels from the same customer gateway, or two different customer gateway. If you have that, you can build it always build two tunnels. So we are good. We are going to say create VPN connection, and this thing is going to take some time here. So I am going to make a pause and come back. Welcome back. As you can see, now we have our VPN connection available, and this is our VPN ID. If you want to know more about what goes into this, select that VPN connection, and all you can see these things here. What is my customer gateway, what type of tunnel we are building, and all those things. Tunnel details. Right now both the tunnels are down, and you can see this is the outside IP address, that means the public IP address of the tunnel. For inside IP address, the AWS is doing something clever here. So they are using 169.254. /30 subnet. So once the tunnel comes up, or for the tunnel, we virtual tunnel VTIs, we are going to use 168, that means 169 and 170 as virtual tunnel interface IP address, and these are non-routable. However, the actual source and destination is going to be outside IP address and customer gateway. Right now, the tunnel status is down, which is obvious because we have not configured our router yet. As you can see, everything tunnel options are default because we chose not to edit anything and live with the default so that we can uh, keep things simple. However, any time you want to change something, what you can do, you can actually select the tunnel and then you can modify tunnel options as well. And once you modify tunnel option, make sure be aware that tunnel will flap and it will take some time to come back. However, we are good with the default one, so let's go ahead and download the configuration so that we can configure our on-prem router. As I mentioned earlier, AWS does provide you some help here, so it let you choose whatever is your on-prem or customer gateway type is. Point Cisco VMs, because this is an router, ISR 1K router. For platform, you will be tempted to choose ISR 1K, but the drawback is, if you choose ISR series router, only IKE V1 is available. So if you want to do IKE V2 with Cisco configuration, CSR VAMI is your friend. Choose CSR VAMI and then you will see IKE V2 option comes live. Now let's go ahead. Everything looks good. We have software version much older than or much newer than 12.4 and above. So let's go ahead and download. This thing is downloaded. And let's look at the configuration together. And then I'm going to quickly use this configuration to configure our router. Apart from configuration, AWS does allow you or help you understand what is in this configuration. So you can read through it. I'm going to probably upload it to my Git page so that if you can come in, read about this. As you can see, we have multiple tunnels, IPsec tunnel 1, and if you scroll down, you'll see IPsec tunnel 2. However, there are a lot of similarities between those two tunnels because the profile and policies, they are duplicated, right? IKE V1 configuration, we have already talked about all this construct in the beginning of the video, so I'm not going to repeat that. Whatever is the comment, you will see the exclamation mark, and whatever is the command, that is without exclamation mark. So this is the first part, IKE V2 proposal, and this is the keyring. Here there are some variable options as well. Look at this. Crypto IKE V2 policy 1, match IP address local, and though it knows what is your customer gateway, it still give you a variable field. That means you need to come and put the actual IP address here. And how you can find that? Obviously, I have that here. It's a better way to copy and paste it in some notepad. So that. So what I'm going to do, I'm going to change this thing here, and where else you need to configure this thing. And I'll do just one for demo purpose and configure the second router later on. Okay, so let's go and start configuring our router. First tunnel, we are going to build the first tunnel, which is go to conf D, and you can see all the commands here. Okay. Like that. I have created the policy first. First, you need to create proposal and then policy. So we will do that. Policy already have some match statement. Okay, that is fine. Now we want to say who we are talking. We are talking to the first tunnel, which is 18.221. Some of the global option, we will do the bare minimum configuration, what is needed. However, you can do a lot of best practices thing. We are not going to do that. So this is our IKE v2 profile where we are calling keyring, and this is our remote and local address. Okay, looks good. So phase one is done. Now let's bring transform set. Transform set. From there we are going to call IPsec profile. Is bring the tunnel configuration. So we are leaving aside some of the best practices. Let me show you. Additional parameter of IPsec configuration, and these are the global behavior. We will stick to the bare minimum, and hence here I'm going to say interface tunnel. I'm pasting it half because I want to say what is my source interface. Source interface is my external interface, which is gigabit Ethernet 000, and then we can bring in the rest of the config, and we'll keep this in shutdown state. Why shut? Okay, ICAM is off. Let's go to AWS. Sorry about that. Okay, we have downloaded the config, and let's come here and check tunnel details. Tunnel status is still down because we have kept tunnel in shutdown state. Okay, what I'm going to do next is not pretty, but let me do a debug IKE, and before we do that, let me just enable logging. So for working one, so anyone who is interested to see what goes in the background, they can look at the logs. Debug IKE v2, debug crypto IKE v2. Sorry for that. To IKE v2. That means I want to debug everything related to IKE v2. So this is going to make it really busy, the router console. Once we no shut the tunnel, TU1, and I'm going to say no shut. And as soon as you do a no shut, you will see all this IKV exchanges, packets, and everything started happening in real time. And this is not pretty. So let's go back to our AWS construct and see what we see over there. Okay, I'll move away from this page and come back again to see. Some details. Voila, tunnel is up. The VPN connection is not using both the tunnel. This mode of operation is not highly available, and we strongly recommend. So AWS want you to configure both the tunnels because it provides a tunnel health monitoring by default without any charges. So this is what we can see we have the tunnel up, and let me just stop the debugging. All debugging turned off, and I'm going to say show IP brief. What we are interested in, tunnel 1 status 169.254.129.170, the same /30 subnet. As you can see, the tunnel is up. However, what we miss from our side is the static routing. So we have not created any static routing so far. So let me go ahead and create a static route. We want to go to AWS VPC, and for that we are going to say IP route 172.16. That is my VPC subnet over there /20. So that is going to be 240, and we'll see the interface is tunnel 1. And AWS does give you that option as well, though it doesn't get the subnet right. So you have to make sure that you are using the right subnet. Okay, so we have static routing available. Let's see if we can go to any of the AWS servers, VPC servers. So for that, I'm going to go back to my EC2 instance, and I have only one EC2 instance running, that is in my private VPC. So you want to make sure, if you want to verify the subnet, you can see the subnet here. It is 0.54 and subnet. This is, let's try to see if we can reach the private IP address. So for that, I'm going to come here and say ping. Obviously, you need to use the source interface because not every VLAN have the outside reachability. So we are going to just use source interface, our outside interface. And though we have the static route, we cannot reach the private servers. Why is that? Maybe let's look at the security list or security group associated with that. Security and inbound security rule, we have 22 and 80. However, we do not have the ICMP echo or ICMP reply. So what do you want to do? You want to go to this security group, and then you want to edit inbound rule. Add a rule. I want to do all ICMP IPv4, and you can use the outside interface IP address of the router. For the simplicity, I'm just going to say all and say save rule, and let's go back and see if that make any difference. Yes, that does. So now this is my router. It can connect to a private subnet, a private resource on AWS, and that it does that via IPsec tunnel. Now let's verify some of the networking construct, and for that we have show crypto IKEv2 SA detailed. We want to know everything about the IKEv2 detail. As you can see, this is my tunnel ID, source, destination. We do not have any front VRF, so everything is in global routing table here. And what is my encryption? What is my hashing algorithm? And as you can see, the idea to use the default was not very good because we have Diffie-Hellman key exchange, asymmetric key exchange group set to 2, which is not recommended. But just to make this thing quick and simple, we decided to live with the simplest option. Here, as you can see, how many number of messages you are receiving and all those things is shown here. What we can do, we can go one step further and look at the IPsec session to IPsec SA detail, and this is the security association that is used to transfer the actual data packet. So here you can see all the SPI information. What is my inbound SPI? And SPI is kind of like a database which is looked for that tunnel. Everything comes and goes in that tunnel. So a lot of details here. And as you can see, my tunnel is up, our local address and all those things. And since we are using NAT traversal, we are using port 4500. If you there was no PAT or NAT in between, then you will be using UDP port 500. Just an extra detail here. IPMTU. So uh, remember, we do not have to do anything with the MTU, but it may happen that your WAN provider is doing something encapsulation, and in that case you have to reduce your MTU. But we were good with our standard 1500 MTU. Okay, so my inbound ESP is active, and outbound is also active. So this is what you want to see, and we are the initiator. uh, why? Because by default AWS site-to-site VPN expect on-prem device or customer premises device to come and initiate the connection. So this is all good from networking side. Let's go back to VPN. For that we have to go back to VPC, and we are close to our verification. We are at the end of this demo. Static route, tunnel details, and everything is here. I'm going to continue working and put the second tunnel configuration so that it can also come uh, up, and there you go. You have a secure end-to-end connectivity from your on-prem environment to cloud VPC, very inexpensive, right? You are using just your broadband internet connection. I hope you like this demo, and uh, if you happen to build one for yourself, do let me know. If you have any issues or you have any learning, please do share, do subscribe, like and comment. Thank you very much. I'll see you in next interesting video. Thank you.